So I'm talking about statistical process control and my attempts to build this into QlikView. And I want to talk a bit about the advantages of using it and how it can help your reporting and your analysis. So just a quick run through of what I'm going to try and go over for the next little while. So just for a bit of background, I'm based in Scotland. I work for NHS Highland, so there's 14 health boards in Scotland. I'm based, so I'm over here in Inverness. That's where our main hospital is. We have 3 rural general hospitals throughout our patch and many smaller community hospitals. You may notice we cover quite a large geographical area. We cover about 40% of the Scottish landmass. So we've got quite a big patch. So we'll talk about variation and understanding that. So the typical example of variation would be journey to work. You might leave house at the same time, you might take the same route, use the same mode of transport, and give or take, you'll arrive at your destination within the usual, typically normal time. But sometimes, you might catch every traffic light on the way. You might have a flat tire in the morning. Sometimes something happens that it'll really delay you. And this whole idea of understanding variation is kind of key. Also, if you understand or start to use SPC, it kind of changes your way of thinking and changes the way you conduct analysis. You kind of realize that data over time is very powerful, and compared to just looking at 1 or 2 data points in isolation, that can only tell you so much. Looking at data over time and applying these rules gives you a better idea of whether or not what you're seeing is normal, or whether you have got special cause that you need to deal with. And I guess the key to this is, if you're looking at any 2 different numbers, one's always going to be higher than the other. That's not rocket science, but so much work is caused by people reacting to this simple fact. And sometimes that work is not necessary. So the first simple tool is a run chart, and we tend to use it quite extensively in our team. We're working on healthcare improvements. We're working on improving care within our hospitals. We have our staff collecting data around some of the care bundles we're working on, and we plot run charts. So a simple run chart, basically data plotted over time. Center line is the median of the initial baseline period. Extend that into the future, and you start to look for certain patterns within the data. Again, this is from the IHI. Benefits of run charts. You can see here number 2 and number 4. They help with this. And why is it called a run chart? Well, every time the data crosses the median, bearing in mind it's a 50% chance whether it will be across the median or not. The data is going to be on one side of the median or the other. Every time it crosses, you count each one of these as a run, and you count the length of the runs, and that starts to tell you whether or not you're seeing a valid change. So these are the typical rules that are in use for detecting change or detecting improvement or detecting special cause variation with run charts. Typically tend to see shift more often than not. Don't tend to see this trend too often, but it does happen. There's also a rule about whether the data crosses the median line too many or too few times, and also this astronomical point. So I'll talk a little bit about these, and I'll show you what I've been doing in QlikView so far with run charts. Just going back to that third rule there, it's a table which you can use. So depending on how many data points you have, this will tell you how many runs you should expect to see if there's no special cause variation. And normally, too many runs is never a signal of improvement. Normally that suggests there's maybe some sort of inherent variation within the system, such as 2 different people working on the same process over, one during the day, one at night, that kind of thing. We usually tend to look at the too few runs. That's an indicator of improvement. So I'm going to drag across my QlikView screen now, hopefully. So what I've done, I've set a little slider here, so you can, depending whether you're collecting data on a daily basis or a monthly basis or a weekly basis, you choose an initial baseline period. So you see here, as I just move the slider, the period changes, and it's very subtle. I don't actually even saw any change in the baseline median there, but yeah, it moved up a little bit there. So the idea is you calculate your initial baseline median. I'll put it back up to 13 just now. Extend that out into the future, and I start to look for these signals in the data. So the shift is 6 or more points on one side of the line. So here we have 3, 4, 5, and then it drops back down, and then another 1, 2, 3, 4, 5. So not quite getting a shift there. We don't have a trend, which would be 5 consecutive points increasing, or 5 or more, I should say. So then we might need to think about, well, how many runs have we got? Are there too few? I'm not going to count them right now, but I'm pretty sure when I checked earlier on, it was bang on the 15 that we were required for 41 data points. So how did I set this up? Let's dig into the properties a little bit. So actually, I should show you my data model, I guess. It's quite simple. So just dates from the future, so numerator, denominator, a multiplier value. So depending on the data you're looking at, you might want to express it as a rate, and a simple counter. So this is the expression. Basically, the set of variable to link to the slider to capture the number of baseline points. So obviously, as you change that, we're basically just saying using the range fractal function. So the chart functions within QlikView. Basically, starting from if it's row 1, then start from row 1 and look down and calculate the median between row 1 and whatever point we select here. And that gives us our median. Otherwise, there's no row 1, then look above, basically look at the median above and use that value. So I'm going to show you something later on, which hopefully will wow you a little bit. So that's basically just having a fixed median, extend the line out and do your analysis. Moving on to statistical process control, I may as well show you the QlikView first. There are various types of these charts, so I'll talk you through them. So with a run chart, you might see an astronomical data point, but you don't know if it's really out of the ordinary. But with a control chart, it can start to help tell you that. It's quite similar, I guess. You've got a center line. This is the average. When a run chart, it's a median. There are different types of control chart, and depending on which one it is that you're using, the method of calculating the limit varies. So you can't always just use, you typically see people using the standard deviation to calculate the limits. You can't always do that because you won't always get the right answers. Again, there are rules. Anything above the upper control limits or below the lower control limits, depending on the metric you're looking at, they would happen very rarely, less than 1% chance of that happening. Also, any 2 out of 3 consecutive points above the upper warning limit or the lower warning limit, this jigsaw pattern or sawtooth pattern, and having 8 or more points either side of the center line, and this is one we tend to look for, or one we tend to see quite often. So as mentioned, there are various types. The 4 charts we tend to use most often in healthcare: the P chart, the U chart, C chart individuals. So the P chart is simply when you're plotting something that either pass or fail, alive or dead, infected or not, and that tends to be for percentages. The U chart and the C chart, you start to think about areas of opportunity. Could the thing you're counting, does it have an equal chance of happening each time? If not, when you look at a U chart, probably express it at a rate. Also, we use U-charts if more than one defect can occur. So if you have more than one type of infection that could happen, or more than one area, I guess. And finally, the individuals chart, which is kind of a Swiss Army knife. If you're not sure, then use the individuals chart and you'll probably get the same sort of signals coming through anyway. So, should have done that one earlier on. This is the demo model. I'll actually go back on now to the, not back on the QlikView, but this is how I set each of these up. So I'll talk you through. Typically, I mean, most of them have got the same setup. So you probably wouldn't necessarily have to do a set analysis bit each time, but basically calculating the percentage, using the slider again to work out how many points I want to calculate my initial control limits. And the key to each one is the way you calculate the standard deviation. So again, depending on the chart, it's not just the regular standard deviation function that you'll find in most software. You have to do the correct calculation. So if I get back onto again, you can go into properties. Again, just showing you the same again. So you probably wouldn't need to have that necessarily, just because my data model has got different types of chart, but you might not need to do that in real life. And I've also set up a kind of color coding as well. So this beyond the limit basically just colors the point. It's the same value as the P expression up here, but it just sets the color to red or amber, depending if it's outside the limits or not. So this chart here, there's no signal as such because we don't have two out of three consecutive points above the upper warning limit, and we don't have anything above the upper control limit. This again, also I've set the lower limits. Basically, if the limits were lower than 0 or calculated to be lower than 0, we just set them to 0. Obviously, you can't have less than 0, so that's the wee expression in there. As you can see. So, do we have any signals? How about points on the same side of a line? We don't actually have, I don't think we've got 8 points on the same side of a line, not on that chart. The U chart, moving on down here into the U chart, similar setup. Again, I've just set a wee box in here to set the rate. So it's set to per thousand. So if you imagine you're counting something, you express it as a rate per thousand occupied bed days, a rate per thousand operations. You think of it. Slightly different calculation of the standard deviation bit here. I've got the slides. I'll make them available after this. But you can see how it's being calculated. I've also got some Excel templates, so I'll make them available too, so you can start to play around in Excel, and then when you're a bit confident, you can start to build into QlikView. Again, if you just move that around, we should start to see things adjust ever so slightly. With control charts, I tend to take 25 data points as a kind of baseline period, but you can use 20 or so, depending on the chart. With individual charts, which I'll come on to in a minute, you can have slightly less. This is the C charts, but again, this is just for counts. Again, a few things kind of highlighted as being above the limit, but not necessarily being a true signal as such. The individuals chart is, as I said earlier on, it's regarded as being the Swiss Army knife, and more and more now I'm seeing people just being recommended to use this and not to worry too much about the other charts. It's slightly more complicated to set up. It's easier to do, I guess, in real life, but you do have to do a bit of screening to remove limit any out of control limits initially, so it can be a bit involved. I'll show you what I've done here. So again, the X, definitely nothing out of the ordinary. But we start to calculate this moving range first of all. So that uses the FABS function. Basically, you're comparing the current row with the row above and turning that into an absolute value just to get the value of the moving range. use this later on if we're calculating simple limits. This is the average of the moving range. And again, that's a bit more of a complicated expression. I'm not going to talk you through that one right now, but you get the idea. It's all there. You can look at it later on, and you need to use the aggregate and the total to get the overall value of that series. And this other little calculation here, again, we're using that to calculate the limits of the chart down below. So some of these values you have to calculate up front, and then some are being rendered invisible because I don't want to plot them, but I'm going to use them again down below. So we have basically a chart in two parts. You have the actual individual values that are within your data, and then you have this chart below, which you calculate. Let's say this is the variance between each point, and this is the control limit. So anything above here would indicate that the variance from the previous point was out of the ordinary. As I said, you would need to initially make sure that none of the points in your initial period breached that line. If it did, you need to discount that point and recalculate it. I didn't quite get finished off building that into this chart, but that's something I'll keep working on. Just in a quick look at comparing the counts chart and the individuals chart. This is the same data, same values. Using the count, we've got a couple of points here on that above, or just above the upper warning limit. And you can see here the upper control limit using the counts chart, 208 compared to 213 for the eye chart, and the lower limit is 130 compared to 124. So there's a bit of difference, but normally speaking, it should pick up the same sort of signals. Lastly, funnel plots. So if you have a P chart or a U chart, normally you look at it in time order, but in order to create a funnel plot, we change the dimensions, so it's no longer the reporting period. Change it to the denominator, and you have it in ascending order, so from the smallest denominator to the largest. And it didn't quite work out too nicely on this example here, but normally you get this kind of smooth funnel effect with your limits, and you can see then where each individual data point lies. You just remove the connecting line. Again, same idea. This is more for a kind of snapshot point in time. So if you're looking at clinicians' performance, perhaps you might do a funnel plot, and you can maybe start to see, what's going on with that particular individual, or above the norm. And same again for the U chart. So this is all very much fixed limits and lots of manual analysis. I'm going to quickly, hopefully, just go over to something I've been working on. We're just trying to build in some analysis into QlikView itself. So this is a run chart, initial baseline period, and we saw this pattern where we had 9 consecutive points below the original center line, which is what we were looking for. So when we saw that, we rebase the median and extend that out and continue to monitor. So basically this red dot here indicates a target range. So this particular area is already performing pretty much where you want it to be, but we're continue to monitor it. When you're looking at performance analysis, any point within your initial baseline doesn't get counted, so you wouldn't count these values here as being below the median because they're within your initial period. You can only start counting from here on in, and any points on the median get ignored. So you see here, we had 1, 2, 3, 4, 5 points. That effectively doesn't exist. 6, 7, 8, 9, rebase, and extend it into the future. Just going up a level, a couple more examples, and then the overall picture. And I'm also working on rebasing it as a control chart as well. This is still kind of work in progress. I'm not really able to share this yet. I'm still not 100% convinced that the control chart was working as I'd like. The run chart is pretty robust. I've got a couple of applications now.
So John, as you go through all these, I still remember, although it's been a while now, I still remember doing this at a health system, and the data goes up and down all the time. It's not like a smooth sales curve or something that you just see things varying by a percent or two. So the numbers always go up and down like that. Have you found that with your implementation of control charts, you get a lot less questions from users as to why things went up or down? Like, are they used to the point, like, it went up, but it's statistically fine?
Yes,
are you
absolutely.
seeing a change of adoption then that people aren't freaking out?
Absolutely. That's the real advantage of doing this is people start to realize, or that basically anything between these lines is perfectly normal. So you have your average. You can expect it to be around about there, but it could be from any given period. It could be as much as whatever your upper control limit is, or as low as whatever your lower limit is. So over time, yeah, people do get used to the idea, and they start to use the phrase themselves. People start to talk about it's a common cause, it's a special cause. They understand. So it takes a while. It's been a good couple of years, but the terminology starts to sink in as you go to more and more meetings. I mean, pretty much the only charts I produce are run charts or SPC charts. So any meeting that I go to, this is what I bring to the table.
Gotcha. Yeah, I think it's great. I didn't get it this far into it, and so you are going to share this QVW, I'm assuming, or the PowerPoint with the code behind it.
Absolutely, yeah. I'll share the PowerPoint later on. I'm just going to double check because I know I was between different versions of QlikView, and I've got version 11 here that's working.
Yeah, I think there's a lot of great stuff in there. Besides just how you did the calculations, I think people are probably looking at the dashed lines based on how many rows to do and coloring the dots so that, look, hey, this is the only thing you really need to worry about. The rest is just white noise. That's great stuff. So thank you for sharing. I'm going to go ahead and